Hi folks, welcome to our Chapter 2 review for geometry here. So in this case, again, these are just going to be just kind of some helpful video, just kind of answer some questions about what you'll see in the closure and stuff. So just keep that in mind when you're doing these problems. Again, these are all for you to kind of... Alright, so again, I'm not going to go through all of these problems, but in this case, again, I'll go through some of them so that way, again, you kind of have an idea of what you're looking at when you do these. So for 219, again, I'm going to kind of leave it up to you with that. I'm probably going to do this one and this one just to make sure that you have an idea of triangles and parallelograms. Most of you, again, have a pretty good idea with their values now. So with that in mind, we'll take a look at 219. So again, with the first one, what I'm going to do is I'm going to go ahead and split it up. What you're going to notice here, in this case, when you kind of split up that value, you're going to have two different rectangles there. So again, just keep in mind that's the length times width. So area is going to equal, so length times width, or base times height. And again, if I look here, I got the value 15 and the value of 8. So I'm going to do 15 times 8 to get that value there for the center. So when I do that in my calculator, I'm going to get 120. And this is, again, those two lines there denotes inches. So in this case, again, with those inches, again, it's just be like inches squared. And you can put 120 in there. Now, what you're going to notice is, okay, well, how do we find the missing part here for that small one? So if I'm looking, what I notice is, in this case, this entire thing's 8, this entire thing's 12. So if this part, obviously, with the missing part here, this is going to have that value of 4. And then with this entire thing, that's 15. This part's 10. That means the remaining part has to be 5. So we got 5 and 4. So what we're going to do then is just multiply those values. So therefore, 5 times 4. It's going to give you the value of 20 inches squared. And then remember, when we're doing these values, all you got to do is just add them with that result. So therefore, again, you take 20 and 120, add them up, and you're going to get 140 inches squared. Again, so hopefully you did okay with that. Again, my main worry, folks, is not, again, you guys know the formulas, it's just making sure that you can apply them to the specific parts. So letter B should hopefully be pretty easy. C, again, with that parallelogram, we're going to go ahead and take a look at the trapezoid. So again, some of you, we're starting a little bit on the quiz with this one. So letter D, what we're going to do is we're going to do area is equal to, and remember, area of a trapezoid goes B1 plus B2 multiplied by the height and divided out by 2. So remember, when we do this, I'm just going to make sure that, again, we can simplify for the values. So when we do, you're going to end up getting the value of 11 for your base. So 11 plus the value of 8 multiplied by the height, which is 6, and divided all by 2. All right, and when you do that, obviously you're going to do the parentheses on the inside first. Again, do not multiply by 6 until after you added the values of 11 and 8. So therefore, you get 19 times 6, and then all over 2. And again, when you plug that in your calculator, I'll move my thing up there, 19 times 6, divided all by 2, you're going to get 57. So that's going to be 57 meters squared. All right, so hopefully, again, you can do the other two. Again, I think majority of you will be just fine with that, so you should have gotten 57, and then 140 there as well. All right, so flip on the back side. Again, if you're kind of following along, 120, you're just going to name the shapes. Most of you, again, will be able to do that no problem. Just make sure that, again, you know how to classify them. So again, obviously, in addition, so we have those different sections of the test. So one of them is going to be solving for the area for those trapezoids, parallelograms, triangles, and rectangle. These ones, again, we're just going to have in the Venn diagram. Keep in mind also we'll have parallel and perpendicular. And then we'll have the last one with angles. And then we also talked about with those triangles as well. We talked about Pythagorean theorem. That's going to be something that we're going to use the entire year. And then we're also going to talk about the triangle inequality theorem. That'll be a standard. So you're not going to be quizzed on it, but you'll be assessed on it for the test. So again, it should be hopefully pretty easy after you watch that video. All right, so then letter F. So we'll go ahead and take a look at this one. It says graph the following points, then name the shape that is created when you connect the points in the given order. So what I'm going to do is I'm just going to plot these points because, again, just in case some of you struggle with graphing a little bit. With that in mind, we're going to graph n, so that's negative 2, 6. So I'm going to go up negative 2 and 6 there. And then I'm going to go negative 4 and 6 there for A. And then I'm going to go negative 4, 3 for m. Excuse me. And then negative 2, 3 here as well. Okay, so label your points. We got N, A, M, and E. Oops. Sorry, it should be N, A, M, and E. All right, so now I'm looking, I connect the dots there. So I see again which values are going to make that shape. So if I'm looking here, the shape that it created, well, in this case, again, I'm going to try to count the sides. So I go 1, 2, 1, 2, and then this is 1, 2, 3, 4. Now, what you're going to notice is these opposite sides are congruent, so I can put a line through them. And then these opposite sides are also congruent. Now, what you're going to notice is, with those opposite sides being congruent, what we have actually with those 90-degree angles is what we call a rectangle. Okay, so we have a rectangle. And again, the reason why is because, again, with those opposite sides being congruent, but the main reason, again, is those 90-degree angles. Since we have 4 90-degree angles, again, we can say that in its 4 sides, we have the quadrilateral there, which is a rectangle. So, again, hopefully you did that one okay. Back side here. I'm going to jump to these. So this one, it says graph the segment and connect the lines, and then what is the slope? I'm going to do this one with you, again, just in case you're struggling with graph in a little bit, and then we'll talk about the angle part on the back side, and then a little bit of those as well. So 121, what it's saying is graph the segment of the points negative 4, 8, and 6, 3. So I'm going to go ahead and graph those. So I'm going to go over negative 4, and then up 8, and then I'm going to label that A, and then B is going to be the value of 6, 3. So I'm going to go ahead and connect that segment. You're going to notice, again, this is very similar to the quiz that we actually took. So again, hopefully you did okay with that. So remember, rise over 1 is our slope. So we're going from A to B. So I'm just going to count down. And then again, if you need to make your marks, please do. So I'm going to go 1, 2, 3, 4, 5. 5 there. So 1, 2, 3, 4, 5, just to make sure. And then again, write that. So rise. Then we're going to go over. So 1, 2, 3, 4, 6, 7, 8, 9, 10. So therefore, we have a slope of 5 over 10. And since we're headed obviously down with that value, it's going to be negative. So the slope has to be y equals negative 1/2. Now it says write an equation for a line that connects the points A and B. Well, if we're looking at the equation here, again, it's just going to keep that slope of going down 1 over 2. So y is equal to negative 1/2 x. And then again, since it crosses, if I keep going down, I go down 1 over 2, down 1 over 2. It's going to cross that value at 6 there. So therefore, again, it's going to have that plus 6 value. Now it asks us to write an equation that is parallel to AB. So again, the nice thing about this one, we can write the equation because we know the slope has to be the exact same. So y equals negative 1/2 x. And then in this case, we're going to write an equation that is perpendicular to that one. So again, I can do plus 0, plus 2, or whatever. So I'll just do plus 2. And y is equal to, now remember, perpendicular, opposite reciprocals. So therefore, again, we flip that fraction. So negative 1/2 becomes 2 over 1. And since we drop that negative, it's going to be positive 2x. And then I can just pick the same intercept. So y equals 2x plus 6. So we get that value there. All right, so hopefully, again, you did okay with that. So that'll be another part of the quiz or test. So again, I'm hoping for good things here, especially since you were assessed on it in Chapter 1 as well. All right, and then 122, if we look at the bottom here, it says identify the geometric angle relationships for each of the diagram. Use what you know about the relationships to write an equation for x and solve for it. So we're going to name the relationship and then find the value of x, much like we did on the quiz. So first one I'm looking at is and saying, all right, well, we have parallel lines, and you have x plus 15 and 102. What I'm looking at here is I'm saying, okay, well, they're not alternate interior angles because, again, they're not on the opposite sides. They're not same side interior angles because they're not on the inside. They're not supplementary because, in this case, again, they're not lying on the same line. So that kind of leaves one culprit. In this case, again, this is what we call corresponding angles. Because in corresponding angles, what they are is they are congruent angles at each intersection of the line. So here's an intersection right here. Here's an intersection. So corresponding angles, if you remember, they are actually congruent. So what I'm going to do then is I'm going to take that x plus 15 and equal it to 102. So what that means then is I'm just going to solve for x by subtracting for 15. X equals, and we do in our calculators, 102 minus 15. We we get 87. So in this case, that value of 87, and we get that value there. So hopefully, again, you're okay with that one. Again, majority of students, I think, are doing pretty well with it. All right, then letter B. It says here that, again, we're looking at these angles. So we have x plus 21 and 7x minus 3. If you remember, we threw up the x, or we have a bow tie there. So these ones, these intersecting lines yield a congruent angle. So then, in this case, x plus 21 and 7x minus 3, they're both going to be equal. So x plus 21 is going to equal 7x minus 3. And we're just going to solve for it just like normal. So in this case, we're going to take that x value, move it on over. 6x minus 3 is going to equal 21. Add the value of 3 over, so we get 24 is equal to 6x. Divide by 6 on both sides, x equals the value of 4. All right, so hopefully, again, you're doing okay with that one. And again, if we're writing the property for it, what we call vertical angles. All right, and we take a look at letter C. Letter C here, it's got the value of 2x plus 2 and 3x plus 8. These ones, what we're going to notice is they kind of create the intersecting lines again, but now what you're going to see again is we don't have anything across from each other, so not opposite, but they do lie on the same line. So that 3x plus 8 and 2x plus 2 are going to be added together. And the reason why is because we call these supplementary. So supplementary, again, supplementary angles specifically, we have a value that they all are equivalent to. In this case, the value of 180 degrees. All right, so we simplify those. We're going to end up getting 3x and 2x, which gives us 5x. 8 and 2 gives us 10, equal to 180. Subtract by 10 on both sides. We're going to get 5x is equal to 170. And then we're just going to take that value and divide by 5 on both sides. So 170, divide by 5, gives you the value of x equals 34. So there's your value, and then again the x value that goes with it. All right, and then letter D. This one, again, is probably the trickiest out of the bunch. And the reason why is because we got to be careful here. So what it's giving you, and this is probably going to one that you'll see on your test. Again, this one is probably, most students will say, hey, this is triangle sum theorem, and you'd be totally correct. So we know whatever we have here is we need to make sure that that value equals 180, so whatever it is. Now, some of you are going to be like, yes, we got x there, we got 2x minus 6, but what about this thing? Well, in this case, it's actually going to be another value of x. So if I look here, this is an isosceles triangle, because in this case, if you look, we have two congruent side lengths. Now, those opposite angles that are associated with them, so in this case, the one here and the one there, eventually, that we draw in, those are going to be actually equal. So in this case, we're just going to put x and x there because they have to have the same value. So I'm going to do x plus the value of x plus 2x minus 6 and equal it all to 180. All right, add the terms together, x, and 2x gives me 4x minus 6, all equal to 180. Add 6 to both sides, you get 4x is equal to 186. And then divide by 4 on both sides. And you get a value of 46.5. And that, again, is for both of those. But in this case, again, you're just asked to solve for x. All right, so again, these are probably going to make up a bulk of, again, the standard. So again, just make sure that you understand the different angles, properties, and then being able to solve for those values there as well. All right, and the last side, we're just going to go ahead and flip on there. So this one, again, a little bit different. So again, we talked about the area of perimeter. We talked about angles, and then we talked about parallel and perpendicular. So what it's asking you to do here, it says, examine the system equations below. Solve the system below twice graphically and algebraically. And we're going to talk about that here, how to do it in a second. So verify the solution from the different methods are the same. What is the relationship between two lines and how can you tell? And then solve the system below using your method of choice. So what we're going to do is we're going to go ahead and graph this first. So in this case, we're going to solve graphically. So the first thing I'm going to do is going to go ahead and graph the lines. First one is going to be negative 2x plus 6. So I go up to the intercept, graph that value positive 6, and then I'm going to go down 1 over 2, or excuse me, down 2 over 1, and I'm going to keep that pattern all the way down for the end. All right, and again, extend those lines. Not too bad for simply doing it by hand. So we got that line there. Next, we're going to do the 1/2 x minus 9. So I'm just going to go minus 9. I'm going to go up 1 over 2, 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 and then down 1 over 2. So then this one makes a line right there. Now you may ask yourself, well, where is the solution? Well, you're going to notice the solution is right there. Specifically, it's at the point 6 and then negative 6. So therefore, I can write that there. So you're going to ask yourself, well, what is the relationship between the two lines? Well, in this case, what you're going to notice is, again, obviously these lines are what we call perpendicular. And the reason why is because the slopes, again, opposite signs, and they're reciprocals, meaning they flip. Alright, so now we solved it with the graph. What we're going to do now is we're going to solve it with algebra. So what you're going to notice is both of these are equal to the value of y. So what I'm going to do is I'm actually going to take them and set them equal to one another. So therefore I'm going to get negative 2x plus 6 equal to the value of 1/2 x minus 9. Alright, so now what we're going to do is we're going to go ahead and put our terms together. So in this case, what I'm going to do is I'm going to add that value 2 over to the 1/2. So I'm going to have 6 is equal to, and then if I add the value 2 to 2 and 1/2, obviously it could be 2.5. I'm just going to leave it as that fraction. In this case, it would be 5 over 2 if I added those. So 5 over 2x and then minus 9. Then I add the value of 9 over, which gives me 15, equal to 5 over 2x. Now what I want to do again is simplify. So if you look here, you have something being divided by 2. I'm going to multiply it out. So I get that value. In this case again, 15 times 2 gives me 30, equal to 5x, because again that's left on the top. Then I just divide by 5 on both sides, and x equals 6. Again, feel free to leave it as a decimal, folks, if you are more comfortable with it, but again, you can use those fractions as well. So we have the x value of 6. Now you may ask yourself, well, how the heck do we get the y value? Well, in this case, you can just plug in the x value to get the y. So therefore, negative 2 times 6 plus 6 will obviously give you that value of there. So therefore, negative 6, so negative 2 times 6 gives you negative 12 plus 6 gives you the y value of negative 6. So there you go. All right, so again, just being able to kind of apply those methods there to be able to solve for them. All right, and then 124, it says Charlotte was transforming the hexagon, so she had the 6-figure side there. It said, what single transformation did she perform from diagram 1? So if we're looking from here to in diagram 1, what it's saying is we're looking here. If we look, A and B actually flipped. C and F actually flipped, and then D and E actually flipped. This is what we call a reflection. And so again, it was just a reflection over whatever axis or whatever point they had as a line of reflection. For letter B, it says, what is transformation did she perform in diagram number 2? Well, if I look here, in this case, obviously the C value went here, B went from there to there, A went from here to there, and then so forth. So if we're looking, what we might have noticed is we have what we call a rotation. And that rotation is probably right in the center. In this case, again, we just probably spun it around, but just keep that in mind with those values. All right, and then for letter C, what transformation didn't she do? Write the direction of the type of transformation hexagon and perform it. So if we're looking here, again, the only one she didn't do, we did a reflection. Rotation is what we call a translation. Write the directions of the type of transformation for hexagon and perform it. So in other words, a translation, what it does is what does it do? Well, it slides. It slides over and orientation doesn't change. All right, and with that in mind, again, if you were to just kind of draw an example here, so again, I'll do my rough shot hexagon. So we have A, B, F, E, D, C. The translation would be, again, just somewhere would it move. So it might move up, it might move over. Again, we don't really know. In this case, again, it ends up in that same spot there. All right, so hopefully, again, you got that. Again, that translation there. Just knowing that, again, the difference. Usually, again, you can tell reflection, rotation pretty easily, but just make sure, again, that you know those for those as well. All right, and 125, explain what are you doing to find the perimeter of a flat shape. How is that different than finding the area? So again, if you're just finding the perimeter, again, you're just talking about the outsides. So the perimeter and the outsides. And when you're talking about the area is the amount of space a figure takes up on the inside. And again, we calculate area in a bunch of different ways. Perimeter, again, you just find the values and you just add them up all around. All right, so with that in mind, hopefully, again, that answers your questions. I feel like I did a pretty good amount for you. So again, hopefully answer your questions and such. Please don't try to copy this. Again, this is kind of more of a resource for you. So that way, again, if you feel like you got stuck, again, at least you can be able to check this video back for later. Otherwise, make sure that, again, if you are looking for any more practice, again, Toolkit is a great way to go about. Again, a couple of problems in there sometimes we don't get to. And then the other part, just make sure you look back at your old quizzes, because again, a lot of those problems will be looked back on as well. Otherwise, have a great rest of your day. Make sure you're good for the sub, and please let me know if you have any questions. Have a good night. Bye.